All right, hello everybody. We are going to start the second season of REHAU Academy On-air. So this is a podcast series that we did a couple years ago where I interviewed different industry trainers and things like that, kind of a teacher's lounge type schedule that we put together, other industry trainers and things like that. For this season, we're going to change the format a little bit. I'm still going to pick a topic and then pick an expert for that particular application or different use of a product or something like that. So the first one that we wanted to start with is snow and ice melt systems, and my guest is Mike East. So before I get to Mike, my name is Max Rohr. I'm the Marketing and Academy Manager based in Leesburg, Virginia. I like to say that I teach people to move energy well with water. Buildings are a really important part of the total US energy consumption, about 40%. So what we do in the heating and cooling and plumbing industry is a very important piece of our infrastructure, and it's something that we should be proud of as a trade and as an industry. So it's something that I'm passionate about and have a very fun job that I get to talk about this type of stuff all the time. So my guest today is Mike East. He's one of my coworkers at REHAU. He's a business development manager in Colorado Springs. Mike, do you want to introduce yourself?
Yeah, sure. Thanks, Max. So, yeah, I've been working for REHAU now for 12 years, and I handle all of REHAU's PEX-based products for construction in the mountain region. So radiant heating, plumbing, snow and ice melt applications, and mainly in Montana, Wyoming, Colorado, and New Mexico. So we have a lot of opportunities to look at and be involved with snow and ice melt systems, particularly in the mountains, but all over in the Front Range. In the cities, we just see more and more opportunities, more and more businesses, public spaces, hospitals, libraries, lots of different opportunities for snow and ice melting. So I've had a lot of opportunity in this part of the world to be involved with those systems. And I just get passionate about anything related to hydronics. Every project is a new problem to solve, and it's a puzzle. So I've always been passionate about hydronics and radiant heating, and I've been doing it for almost 22 years in the industry, both as a wholesaler and now with REHAU for the last 12 years.
Great. Yeah, thank you. And thanks for being the co-host with me today.
You bet.
Okay, so what we're going to do is run through a little bit of an agenda, but we also want to have plenty of time at the end for questions. So if you are listening live, you can use the chat question feature in GoToWebinar to type in a question at any time. We'll kind of keep an eye on those. And then once we get through about 20 slides, we'll stop and take a look and get deeper into the questions if it's something that's about the topic in general that we hadn't covered at that point. So the agenda, we're going to talk about SIM, which is what we call snow and ice melt systems, the history and background. We'll talk about some installations, and then the projects are kind of my favorite part to see what our cool industry partners have done over the years to solve some major problems for snow and ice melt systems and use it creatively. So snow and ice melting is not a new topic. It's been around in North America since the 50s. Like radiant heat, originally they used wrought iron pipe. Those systems didn't last that long because the concrete and the wrought iron were not the best chemical romance, I guess. So those systems failed. Now we use PEX because that is the appropriate plastic pipe to use in a concrete slab. It's easy to work with because it's flexible, and then the concrete isn't attacking it the same way that it would with wrought iron. So that's kind of the technology shift, but the concept's been around for a long time. So you can see the pictures on the screen there. A lot of commercial settings, kind of entrances to big urban buildings, driveways, and things like that. And then we'll talk about some of the things that we've done more recently. But Mike, what's one of the older snow melt systems that you know of?
Well, yeah, as long as I've been in this business in Colorado, I've been seeing these systems going in. I'm thinking back to 20 years ago, seeing PEX pipe being laid down into some of the streetscapes in Vail, Colorado. So 20 years ago, these systems were going in pretty routinely.
Yeah, and I think that the mountains are definitely going to be a big market for us, as we'll kind of show through some of the different slides. But one of the things that we like to keep in mind too is that there is a lot of snow in the mountains, so it seems like a good fit. But anywhere that it gets cold and ice is possible, it's definitely something that can be a big advantage for the occupants and different building owners. So to start with, let's cover a couple of the primary reasons that people look at snow and ice melt system. So convenience is probably the number one thing, that instead of having to shovel or having some sort of snow removal truck or series of trucks to come and move and haul the snow out of the way, it just melts in place, so you don't have to think about it, you don't have to do it, it just automatically goes with the controls. And then increased safety, so that would be not taking that first step out of a commercial building onto an icy, snowy patch or something like that. That's one of the primary drivers. So what are some other things, Mike, that people will make the decision to go to a snow melt system?
Yeah, well, I think that liability issue is one of the biggest drivers, that when we see these going in more and more commercial spaces, but then also just accessibility to these spaces. And outside of a museum, for instance, down in town, Colorado Springs, right now they're building a new Olympic museum, and there's going to be, lots of heavy traffic coming in and out of this building, and making sure that that's always free of snow, and that you're not tracing snow melt chemicals or salts or things like that from the outside into the building, into what's certain to be beautiful decorative flooring and things like that. So I think that accessibility and maintaining those decorative surfaces in and out of commercial spaces, it makes a lot of sense with a snow melt system.
And one of the questions that we get asked sometimes is, am I going to save money with the snow melt system? And I think that there are a couple cases a year that it makes sense if you pencil it out like that. I wouldn't say that cost is the primary driver for a snow melt system. The least expensive way to get rid of snow is to go shovel it. The least expensive way to get to work is to walk instead of driving a car. So there are some cases, depending on maybe annual snow melt contracts that you've been maybe overpaying for, or there is some of those setups are you pay for the year, and if it snows once or if it snows 100 times, you pay the same amount. So there's a lot of kind of budget ambiguity to that, where with the snow melt system, it's going to power up and melt the snow only when it snows. So that way you at least have a match of the amount of times that you're melting snow with the amount of snows that you have. What else would you add to kind of that conversation, Mike?
Yeah, and there's two pieces. There's the operational cost, which kind of covers the things that you just talked about and is important, but then also that upfront investment cost of building the system. And certainly if we can think about incorporating a snow melt system in our initial phases of construction, when we're building the building the first time, it can minimize the cost of having a snow melt system in your building. It's more difficult after the fact to go back and try to add pipe into an existing slab and those sorts of things. But also, if it's a commercial setting and we already have heating water boilers, we already have pump systems, and we have the opportunity to put the piping system in the slab during the initial phase of construction, then we're going to sort of lower a lot of that big capital hurdle that you might be thinking about with a snow melt system. So it might not be as expensive of a leap as you might think. And then operational cost, depending on where you are in the country, and if you're otherwise going to be having to remove snow with equipment or with a service contract or some other legitimate expense, and that operational cost can be fairly neutral down the road. So putting it in, I guess the takeaway when we're building a new building, minimizes that capital investment as much as possible.
And I think that one of the other things that when I used to work in Colorado as well and sold snow melt systems with boilers and controls and things like that, there were some cases too that liability was such a looming threat that they just said, we just have to keep this twisty garage entrance that goes under our building clear, because we can't have people sliding down and bumping into all the cars and equipment at the bottom anymore. So there are some liability pieces there. I don't like to lean on that so much as the the scare tactic, but there are definitely cases where that is a primary driver for people, that they just can't have an increased risk of slip and falls, and this is a good way to at least reduce the possibility for something like that. But in the US at least, someone can sue you for anything at any time. So just having the snow clear doesn't guarantee that nobody's going to take a fall, but that's kind of a side note to the whole snow melt conversation, I guess.
Yep, agreed.
Okay, so when you start looking at a snow melt project, what are some of the questions that you ask? Who is the person that you want to talk to when having a snow melt conversation?
Well, ultimately, there needs to be some understanding by the building owner, the person who's going to be responsible for how this system performs when it's all said and done and the project is over. So a lot of times we're talking with mechanical contractors or we're talking with engineers, but it's important to communicate to them that it needs to be communicated back to the owner of the building that this is a performance expectation-based system. And that communication of how is this going to actually work and what is that going to look like when it's happening, that conversation happens at some point, because without that conversation, if an owner is building a building and he tells his engineer or architect, yes, I want to have a snow melt system, in his mind, without having that conversation, there's never going to be snow around his building, because he made the decision to put in a snow and ice melt system. And a lot of times that can be the case, but it's really important to understand then how is the building going to be built? What is the materials that the snow melt system is going to be embedded in? What issues are we dealing with on site? And relate that back to the performance expectation of the owner. And depending on what he wants, and is it going to be okay for some snow to be on the system or on the slab during a storm, and then it'll gradually melt off, or no, there can never be one flake of snow that ever accumulates. Understanding what his desire is up front then will drive our ability to try to make a design that will fit what he needs. But we also might find that at the end of the day, that expectation that they have might not be totally possible. So some of those things come up with the design selections downstream, but understanding what the expectation is up front is the most important conversation to have.
Definitely, and I think that the non-technical building owners of the world may, if you don't have a conversation, may expect that it's like a microwave, that as soon as you turn on the snow melt system, that just like in the snap of a finger, all of the snow is gone. And even under the best circumstances, that's not really how it works. With proper controls, it may seem like it was not ever accumulating snow, but it's kind of part of the conversation to have. And that's kind of what we talk about on this slide here too. So that in the more technical presentations that we do, we'll go through this ASHRAE handbook snowfall data. So this is kind of what we use for design and is the background to our LoopCAD software. But it's a window of historical snowfall from 1982 to 1993 in all these different locations. And usually it's like an airport. They're kind of major cities and locations like that. So we may not have every single city in North America listed, but usually a major airport closest to where you live is a good place to start. So in this chart, you have a couple different variables to choose. So you can say, I want a snow-free area ratio of 0.5 or 1. So what that means is that a 0 means that snow can completely blanket the surface and then will melt it eventually. A 0.5 would be some snow will accumulate during a melting, and then an area free ratio of 1 means this is like a helipad. We can't ever have snow accumulate. So that's the first thing that you're looking at. Then the other side, the kind of the x-axis here, is what percentage of storms in that historical window do you want to cover at that snow-free area ratio? So our example A for Amarillo, Texas is going to be a snow-free area ratio of 0.5. So some snow accumulating is okay. we want to shoot for 90% of the historical storms, so that once a decade, twice a decade, huge 3-foot snowfall, we're not planning to melt that immediately or to stay ahead of it. So in that case, the sizing chart that we look at says it's 88 BTUs per square foot, and that is normal. So that's within our range. We put on the slide here that 150 BTUs per hour per square foot is probably a good rule of thumb, probably a good number to shoot for. If we did that same exercise, let's say this is a shipping ramp in Albuquerque, never can it have snow on it, area free ratio of 1, and we want to shoot for 99% of the storms, we get 242 BTUs per square foot. Do you want to kind of walk me through the conversation that you'd want to have at that point if those were the homeowners or the building owner expectations, that 242 number?
Yeah, so, the nice thing that ASHRAE's done here is they've developed this table, this scheme to kind of come up with what would the requirement be to achieve these different levels of performance. And it lets us talk about, can there be any accumulation during the event? How many weather events are we trying to look out for? But then it can also give us a number. And then this is where, in this case, in Albuquerque, 242 BTUs a square foot, then we as system designers would turn around and try to figure out what pipe spacing, where is the pipe going to go in the slab, what water temperature, what flow rate. We might find that that's not an achievable number based on the limitations that we have of the material. Maybe it's a pipe that's going in sand with pavers on the top of it, and we're maxed out on our water temperature and our flow rate. So we look at the limitations of our design, and we might be able to come back and say, okay, for Albuquerque, with a snow-free ratio of 1, we can deliver 168 based on how your slab is going to be built, and with adhering to our design limitations. So now we can go back and have that conversation that, we're going to cover you for 95% of those events at 168, but the 99% of all snowfall events that, could possibly happen, it's not necessarily achievable, and it's not a reasonable expectation. So one thing that can be misleading about this is it's, okay, yes, here's the number I need for my desired expectation of performance, but it's not always a possibility to engineer a system that can deliver that.
And the newest version of the ASHRAE handbook that talks about snow and ice melt systems, that chapter, does some of the updates they made there are kind of to that point, that these numbers, while they are on the chart, aren't necessarily a best practice or reasonable in some cases. But it's definitely something that is good to get ahead of, because there are some people, if you had an airport in Fairbanks, Alaska, and you said there can never be a snowflake on this slab ever, it wouldn't be a good idea to just say yes to that if that was the request. So that's kind of one thing to keep in mind. And that 150 BTU per square foot per hour is a pretty good place to start, and to see if that's a good test to see if that's going to be reasonable or not. So some of the factors that affect sim design, this is all of the background behind snow. So a snow lake effect snow in Chicago is very different than a nice like powdery Utah or Colorado snow. So some of the things the ASHRAE handbook actually digs into a little bit more: rate of snowfall, the temperature, the dry bulb temperature, humidity, wind speed. All of this stuff is kind of built into the calculations that are behind LoopCAD and that are in that ASHRAE handbook set of data. But snow is a pretty complicated thing, is kind of the moral of the story with that one. And they piece all those things together pretty well. So for controls, there are 2 general categories for how we're going to operate a snow melt system. Melting is a mode that you can put these snow melt controls in, that when it snows, it will start melting. And if it's a warm, sunny day in the middle of summer, there's no way that control's coming on. There's no way the boiler's firing up. So it's on demand. When there's a snow demand, it's going to turn the system on and go from there. So idling is a little bit different in that we keep the slab at a specific temperature, kind of like you're idling a car, instead of turning it off and turning it on at every stoplight or something like that. So when you're idling, you want to keep the response time down. So if you keep the slab warmer than just letting it go back to whatever temperature it is outside or whatever the ground temperature is, it's going to be a little bit slower to get it to the point that it's actually melting at that 32 degrees Fahrenheit or warmer. So idling is something that is a good way to go for those very, very critical areas. It is more energy intensive. So there are systems that are idled all winter, and it may only snow 3 times, and you idled it and you were paying the gas bill that entire time. So it's something that I like to kind of make sure that we're definitely identifying the perfect application for idling, instead of just making a blanket recommendation that idling is quicker to respond, because then everybody would do it. So Mike, what are some of the projects that you've worked on that would use an idling mode?
Right. So one good place that you could think about idling would be places that you're always going to have moisture. So maybe it's a car wash, an outdoor, spray off car wash, where you want to snow melt the aprons and maybe even the wash bay, or a commercial maintenance facility where you have wash bays for vehicles and equipment. The moisture is always going to be there. Because that washing, could be happening at any time. So a place where there's, for some reason or another, there's going to be moisture, all throughout the winter season, that could make a lot of sense to just idle those slabs. Also, areas that do have high rates of snowfall and have continual traffic all throughout the winter season. The ski resorts are good examples of this, where it's a pedestrian walkway. It's snowing every other day on a daily basis. They never want to get behind any of that snowfall and allow any snow to accumulate. They might want to idle those areas where we have that consistent snowfall all throughout the season.
Yeah, I think those are good examples. Okay, so there are some snowmelt systems in the world that have avoided using a snowmelt specific control, and they just have a light switch. Please don't do that. Would be my recommendation there. The automatic start and stop snowmelt controls are a great way to go. Some people will look at the price of those to start with and say, oh, I can do this with a light switch instead. There's a lot more going on there, and I would say that in a normal season, you probably pay for that snowmelt control just in reduced energy bills. If you forget to turn that system off, you would have a big natural gas or propane bill, and then also you may end up cracking your snowmelt slab if you end up with a supply temperature that's too high, it's on for too long, something like that. So that's what I always recommend, is an automatic start and stop control to reduce energy consumption and things like that. Just it's the appropriate way to steer a snowmelt slab is kind of the takeaway there. So
I agree, Max. And I would just add real quick is, there have been innovations on the control side in recent years where there are different cost levels to get into that, where now there are some relatively low cost controls that might just use an aerial sensor instead of an embedded slab sensor, and an air sensor, a little bit more basic, appropriate for a residential or a light commercial. That's still a very relatively low cost way to have an automated control. So you're not going to have to blow the budget just to control one of these systems.
And one thing I forgot to mention there too is that some of these controls even have a way to see the weather forecast. So using your zip code or something like that. And it's almost the best of melting in idling, that they can see in the snow forecast that you're supposed to get snow all day tomorrow. So they can even bring the slab up to a temporary idle to get ahead of it before it even starts snowing, to bring that slab temperature up a little bit. But then after it snows, it goes back to regular melting mode, so you don't leave it in that idle. That's the best use of technology, I think, there, is to actually keep, you can almost see it coming through the weather forecast instead of waiting for that first snowflake to start the system up.
Yes, that's a great control strategy there.
So this project, this is Union Station in Toronto. So this is their main train station right downtown. This is a great commercial application for snowmelt. I mean, they get a lot of snow in Toronto and with the lake there and things like that, the heavy, wet snow. But this is just a really perfect place for snowmelt. So as everybody comes in and out of that central train station, they've got all that apron around the building. That's not going to be a slippery step as you're dodging to try and get to your train as you're late or whatever. So this was something that our sales office in the Toronto area worked on. Climatrol was the designer for this project, I believe. Okay, insulation is probably the next long conversation that we usually have with snowmelt systems. So when people ask me if they need snowmelt, if they need insulation under a snowmelt slab, my short answer is yes. There is a longer answer that it depends. So there are some cases that the initial cost of insulation, they decide not to do it for different criteria of that particular job site. I would say in most cases, residential driveway, 99% of the insulation is definitely a good way to reduce the fuel cost. It may even lower the size of the boiler that you need, depending on the sizing and things like that. Mike, do you want to go over some of the cases where insulation and maybe even additionally idling makes sense?
Yeah, exactly. So we talked about some of the situations where we would idle a slab, and in some cases, those might also be instances where the upfront cost and the utility save of insulation underneath that slab might not be justified over time. You're always going to, without insulation, you're going to have more on your back loss side, meaning more of that heat that we're sending out is just going to go down to the ground and not effectively go up into the surface of the slab and melt it the way we want it to. So you're definitely going to sacrifice some efficiency if you don't do it. But that being said, if we're in an area where we're going to idle a slab in a resort all winter ski season long, at some point in the early operation of that system, we're going to get the ground level below the slab. That temperature is going to increase from that downward loss to the point where it's sort of neutralized, and the temperature is going to want to, the laws of thermodynamics still apply, so the heat is going to want to go to the cold surface of the slab above over time. Now, again, if this is a residential driveway and you have an automatic control that just turns it on when it snows, you're going to have a lot of downward loss. It's going to be very slow to react, and the performance might not meet your expectation. But if it's an idled slab all winter long, from an operational standpoint, over time, like I said, you're going to bring that ground temperature up, and the system will still be effective, and that cost of insulation below might not be justified. So that might be some reason. I've also been involved in, and we're going to talk about some of these projects too, where it's like a hangar, and it's an ice melt system in the track of a hangar door for an airplane type facility. And in that case, this slab is very thick. You might be dealing with a 14-inch thick slab, and the slab's so thick that they pour it in multiple pours. So there's a 7-inch pour, and then the pipe goes down on that slab on the top of it, and then there's a topping slab that completes the full 14-inch slab, and our pipe is residing in the middle. At that point, we have 7 inches of concrete below our heating pipe. That effectively is beginning to act as insulation in that case, and you might not need insulation below there. So, there are applications and instances where insulation might not make sense, but in your typical 4-inch walkway or sidewalk or entry, most of the time, it makes a lot of sense from an energy standpoint to go ahead and make that investment and put it down.
Yep, those are good points. So this next slide, I think, addresses a couple of the questions that have come in the chat too. And we've kind of, we've been close to this topic, but wanted to talk a little bit about drainage, because if you melt snow, and it doesn't have a chance to go anywhere, you have an ice rink for a while. So you will eventually evaporate all that water, but it's going to take a while. So ideally, we turn it from a solid and ice into a liquid, and then we have a space for it to drain away. We had a couple questions about drainage and how important that is. Do you want to talk about some key drainage considerations for these systems?
Yeah, so certainly what you're gonna want to, and buildings, you know, typically they're going to grade away from the building, and they're going to maintain those sloping areas to keep just natural rain and runoff from going away from the building. But we want to make sure that, and again, given the size, if it's a driveway leading up to a house 1,000 square feet and it's sloped down towards the curb and the gutter outside, you know, you don't really have to do much to consider drainage in that situation. The moisture is going to melt, it's going to run down to the gutter, and it's going to run off. So, but when you get into a larger area where maybe you have a low point in that slab, that moisture is definitely going to drain to that point, and then will freeze when the system stops running if you don't have a adequate means of removing that drainage through floor drains or something like that to get that moisture removed and off of the area so it doesn't freeze after the melting stops. And then taking thought into if we do need to put in a trench drain or a drainage system, and we have this snow melt piping, running pipes along that drainage to make sure that it doesn't freeze down in the drain piping system below the surface, as well, is a good idea to keep those trench drains or those floor drains warm so they don't freeze up and then back up.
Yeah, and there are some systems out there that are nice snow melted systems, nice grade down a hill or something like that. And then there's a 6-inch ice dam at the bottom. So it's right. Case by case, but yeah, like you're describing, the warmest supply fluid right by the drain, and then actual warm channel for that water to get away from the slab is a best practice there. So we had a couple more questions on that topic. A few of the, let me go through a couple different applications. We generally like concrete as the surface. Mike, do you want to talk about asphalt and paver applications when those are appropriate?
Yeah, so asphalt is certainly from a installation standpoint, there is a couple extra additional things you want to think about. And it kind of would be similar to what we would do in a paver situation. But what we would do if you wanted to have a snow melt system below asphalt, first of all, on the install side, we put the tubing down on a subgrade below where the asphalt's going to go. And that tubing we want to bed in sand to protect the tubing from, because ultimately when that asphalt goes on during the install, it's going to go on and it's going to be hot. So because it's a polymer pipe, we need to embed the pipe in a sand bed. Asphalt goes on top. And then during the actual installation of the asphalt, we want to be flushing cool fluid through the pipes during that process. So that's a little extra step that we would need to consider. But from a functioning, effective standpoint, we can absolutely melt snow very well under asphalt installed in that method. Pavers are going to be another similar situation. We see lots of decorative paver projects, commercially and residentially. And it's a similar situation where our pipe then is going to be embedded in a sand bed, and then the pavers go on top of it. And one thing to think about is it's often going to require a significantly higher fluid temperature than when we're embedded in the slab itself, because we're in the sand, and the sand's not a great conductor. But the pavers are going to need that sand bedding to install the pavers on. So the pipe resides in the sand bed, the pavers on top of that, and then the moisture is going to drain down through the pavers, through the sand bed, then to the subgrade below that. And in some cases, if those are on decks or pedestrian areas, and it's that subgrade that needs to be graded down to our floor drains or our trench drains or our moisture elimination concepts. And that's going to be done at the subgrade below the sand bed, below the paver.
Yeah, and one of the questions we had in the chat was that sometimes omitting insulation on a paver install can be a way to go because of drainage. So with concrete, you're going to have the ability to have the water run to the edge of the concrete. It's not going to go down through the concrete. With pavers, you've got all of those spaces in between that it can seep down in. And you can still do drainage like we've got shown on the slide there. But in some cases, if drainage isn't an option, that may be part of a bigger conversation to have about insulation too. And where is the water going to go? Do we need to just let this go down and through eventually? But depends on how much it snows too. So drainage of some sort would always be a good recommendation.
A good recommendation, but I do agree with that. I mean, I've seen a number of paver installations where there is no insulation used, and yeah, part of that is that drainage is that we want that moisture to be able to filter down and through, and there's a price to pay for that from an efficiency and operating cost standpoint, but sometimes from a constructability and drainage standpoint, it can make good sense to do it that way. So again, it's back to there's never a right or wrong answer. It's just what is the situation and what's the best solution.
Yeah, and one of my snowmelt mentors, Greg Gibbs, typed into the chat as well. One of the things to mention here too that we didn't mention at the very beginning, but it may be very expensive to remove snow from pavers to put it into a truck and haul it somewhere in cases where they don't have anywhere to put it. So some of those things may play into this as well. If you really want to, from an architectural standpoint, have pretty pavers outside of the building, it may make a lot of sense to do snow melt because it would be very expensive to continue to tear that up with the snow plows, all the damage that's associated with something that's not quite as uniform as concrete, and then scooping it and hauling it to other places. Those are some of the things that come into play, especially in areas where it snows a ton, that can really factor into that conversation about the overall price of the system.
Absolutely agree.
Okay, so let's see. One of the things to mention here too from the questions is with asphalt, that is possible, and I'm not the asphalt expert by any means. You'd want to talk to those people, but there are ways to do like a cold pour of asphalt, or you'd have to circulate water through the pipe to keep it from overheating, which can be a trickier install. So we've done stuff like that before, but it's definitely not quite as easy as a concrete pour.
That's right.
Okay. So this, if any of the REHAU designers are on the phone, this is something that is a good amount of capacity that we spend in the design phases trying to figure out and kind of walk down manifold locations. Do you want to talk about why manifold locations are so critical and ways to kind of troubleshoot tricky job sites?
Yeah, this is another good one that comes up often, and again goes back to that original owner or architect as the concept. I want snow melting around my building, around the exterior of my building, and again for our residential driveway, that's 1,000 square foot rectangle extending right off of the front of a home. It's real easy to have that origin point of where all the pipes that are going to accomplish that, where they're all going to run back to, so that we can connect them back up to the heat source, ultimately back in the mechanical room. So we can put that manifold right on the inside of the garage and feed the pipes right out into the slab, and that's really easy to accomplish. But from any individual manifold location, a safe rule of thumb is that we can cover about 2,000 square feet. So we get into a commercial setting and they have 5,000 square feet of sidewalks and walkways and entrances around the building that they want to take care of. It's not practical to cover all of those areas from one single point. So whenever I see a set of drawings and a landscape where they're showing we want snow melt, my mind initially starts breaking that up into approximately 1,500 to 2,000 square foot areas, and with the notion that we're going to need a manifold to supply each one of these sub areas of the snowmelt. And then you start looking at, okay, is there a place that makes sense right on the building that's easy to distribute piping from the mechanical room to that manifold? Or do I need to put it out in the landscape or on an exterior wall, or looking at the site and thinking about where's that manifold going to go and how am I going to feed fluid to it? And then the other part is we have the pipes themselves. We have a circuit limitation there too. So if we get into a long, skinny walkway that it's only 1,500 square feet, but it's 400 feet long and 3 feet wide, that might impact where does that manifold need to be located as well.
And maybe we can kind of look at this specific slide here because it's kind of what you're describing. So the bottom left there that we've got circled is a good location. You've got a manifold that's kind of right in the center of a big rectangle. And then the other manifold is at the end of a big, long, hockey stick shaped space. So what are some of the concerns with this type of manifold location?
So one of the things that happens in this type of installation is, well, first of all, from a budgeting standpoint, if the person had that total square footage number of the area to be snow melted on the right, that's circled there as a tough location, if someone just said, okay, this is the total square footage of that, and they did their formula to figure out with pipe 9-inch on center, how much pipe is going to go in there, they would have budgeted for a certain amount of pipe, assuming that it's all 9-inch on center throughout the entire area. Well, in this configuration, we've got pipe on 2-inch on center, having to feed tails back and forth to the manifold just to get out to, I'll say, the meat of the area. So we end up with a much higher density of pipe, which means more material than maybe you would have budgeted for. And then also just from a practical standpoint, to have all of that pipe on a really, really tight spacing, it could potentially start to become an issue for, the concrete where, they're actually looking for some space for the concrete to go in between the pipes. And we've got just this solid, wall of pipe on the ground there. So a better manifold location, if it would have been possible, would have been down, perfectly towards the bottom of the pay, bottom corner there. Had the manifold been able to be situated there, that would have made this a much better scenario. Now, again, is it possible given the pipe routing inside the building? All of these are considerations, and sometimes we just have to deal with tough manifold locations. But again, being able to have that conversation with the architect or the mechanical engineer or the designer beforehand can be really helpful and make it a much easier installation when the time comes.
And one of the tools that I know that you guys have used in the mountains a lot is a pre-insulated supply and return pipe like INSULPEX. Maybe give me an example of when that would help you kind of space out your manifolds a little bit more.
Right. So often, again, back to say it's a long sidewalk area where the sidewalk is so long down and back that we couldn't put the manifold right by the building and have the circuit reach out to the end of the zone that we're trying to cover and then make it back. So we do have some limitations there of how far we can go. So in this case, it makes sense then to move that manifold out into the landscape area located in the middle of that long sidewalk and then extend our circuits either way. In that case, we need to supply our heated fluid from the mechanical room outside the building out to the manifold. And this product is a perfect way to do it because it already has the insulation, it already has the jacketing, it's flexible. We can run a trench out to where that manifold would need to be located and extend this pipe from the building out to that manifold location and deliver the fluid there without much heat loss and with a material that's easy to work with and can bend around trees or landscape or other things that they might deal with out on the job site. So we definitely have an ability to supply that. But again, back to understanding the manifold locations. If this type of a delivery system is required, there's going to be an impact on the total cost of the system up front. And this is one of the most often overlooked elements of snowmelt jobs that I see, where an area is designated in a building and it's budgeted off of a price per square foot, and no one considered that remote manifolds were going to be required, and what is the material cost and labor to feed those manifolds. So it's important, it can have a big impact on the job if it's necessary. So understanding those manifold locations and the areas you're trying to heat is again, a very important early conversation that should be had.
Yeah, and I think that the best systems with that type of installation, just from a peace of mind standpoint, the connections that you're making might be in the building by the boiler, and then at the remote manifold with no joints in between. So that's a nice thing too, that you're just not worried about welding in a ditch all summer to make all the turns with steel piping or something, or copper, or then insulating it to get to that location. So it's definitely an easier install and can give you that peace of mind that there just aren't more connections than you need to do it.
Right, and thermal expansion, which, yeah, if you were trying to feed exterior manifolds, underground piping with any type of metallic piping system, thermal expansion is going to be a major issue that you'd have to plan for, and expansion loops and thrust blocking and all the rest. Whereas this PEX pipe, it can accommodate and handle all that without, making any special exceptions.
Yeah, those are good points as well. Okay, so what we wanted to leave some time for here is to talk about some of the different use cases for snow and ice melt systems. So we mentioned transportation hubs like a train station, airport hangars, things like that, public entrances. One of the things that we talked about before the presentation, and just kind of as we talk about snowmelt from a marketing standpoint, is we usually talk a lot about mountain installations, ski areas, and things like that, because there are a lot of snowmelt systems up there. But something like a car wash, even in Pennsylvania or Ohio or something like that, might be a good way to go with snowmelt as well, because you may not have snow that day, but you have water, and you're dragging that out onto a 28-degree Fahrenheit apron to that car wash or something like that. So you could be making your own snow. Some of those things are definitely not mountain specific. So what are some of your other examples that aren't really ski area related?
Well, yeah, like I mentioned, I am seeing more and more even retail commercial spaces where trucks might have loading docks where they're needing to back down the slope back and forth to offload trucks in commercial settings. The entrances, walkways to those retail spaces. See it a lot in any kind of public new building that's going on. So, we see it in, downtown Denver where, yes, it snows, but it's not like the mountains. And we're seeing on the Front Range in Colorado, libraries, theaters, judicial centers, any public space that people are going to be entering in and out, with a high level of occupancy all throughout the day. All those critical areas is very appropriate for snowmelt applications, just because of, I think a lot of that's going back to the liability topic that you spoke about earlier, Max, but it's just making sure that people can safely access these buildings, even if there's just a little, bit of snow in the morning that could have iced things up, to just not have that potential liability. It makes a lot of sense anywhere that it's cold and you get any amount of moisture. It doesn't have to be a ski resort.
Yeah, and I think that especially in critical things like hospitals and entrances like that, it would be a bit of a disappointment if you had a life flight land and someone's, in bad shape, and then the first step out of the helicopter, you slip and break your leg as an EMT or something like that. That's just like, right. That's not what we want. So those are some of the things that we can help to do there. And we just had a kind of a flood of questions come in with that. So one of the topics that I wanted to address here too is that one of my favorite ways to go instead of pavers is to do stamped concrete. So with that kind of texture that they can put on as they're finishing the concrete, so it almost looks like pavers, but you have the efficiency benefit of embedding the pipe right in the concrete still. So some of the advantages there is that stamped textured concrete or pavers, you can't really plow that super well, or else you're going to damage it, crack some of the edges to it. De-icers may be something that wears off the color or the top surface of those surfaces and things like that. So I think that that's a great way to go, and it's something that I'd like to present as an option to work with snow melt slabs.
Yeah, you're right, Max. That's a perfect place to put snow melt.
So let's see. Yeah, we had another comment about hospitals being a good use case. Okay, so why don't we go into a little bit more detail with a couple of these other projects that are some of my favorites. The Solaris Town Center was an example. This is kind of the prime example that I bring up along the lines of that comment that Greg Gibbs left. So on the top right, I used to work in this territory. There's a big fancy condo complex hotel. I'm not sure what all the spaces are. The people that live in the penthouses of those buildings that are looking straight up at the Vail Mountain, they weren't that crazy about all the snow removal noise. They didn't like the big dump trucks coming down the street at 4 in the morning and making all the beeping noises to scoop up the snow. They had to physically haul it down the street to another location to melt it in a big parking lot because they didn't have anywhere to put it because it stacks up so quick. So this was a cool project in that way, that there were a lot more considerations than just the simple convenience here, but it was also a great project from an installation standpoint. Do you want to tell me kind of the cool aspects of like the stairs in this project?
Yeah, so there was a number of things you can see on the picture on the right, upper right. The surface are these really nice, beautiful, decorative, natural stone tiles. So there again, not only is it a really nice aesthetic, but it's not very easy to shovel. It's going to be damaged. So snow melt makes all the sense in the world to automate that process and take care of it. And it's going to allow that to be in place without being damaged for a long, long time. In the flights of stairs that lead from the ground level up to the mezzanine shopping level of the area, they had these outdoor stairways, and they wanted to use the same type of beautiful natural stone tread on top of these stairs, and then there was kind of no riser in between there. So it's sort of these floating treads going up to the stairway on the second level. So it's going to be a really nice look. But when we looked at how are we going to run our PEX pipe in that system to be able to melt those stairs, because that's an area that you definitely want to keep free of snow, a floating staircase like that. So that became a little bit of a trick. And we ended up going with typically we would run a 3/4 or 5/8 inch pipe in the snow melt system so that we can run long lengths and minimize the head loss on our system. But in this case, we did use 1/2 inch pipe because we needed the flexibility to actually be able to thread the pipe down through the steel beam and thread it from stair to stair and then loop along the riser. And then after the pipe was put in, then a mortar mixture was put over the top of the pipe, and then the stone paver went right over the top of it. And we're effectively melting those stairs using the flexibility of a smaller 1/2 inch pipe, but at a pretty tight spacing embedded in those stair treads. And it functions very well, and they still were able to get the aesthetic that they wanted. So that was a unique challenge when they first brought it to us and said, hey, how are we supposed to run the pipe into this onto these stairs with no risers?
And is this something that they just idle?
Yeah, this system pretty much runs throughout there is a building automation system, so they might be using some of that forecasting stuff that you were talking about. But yeah, for most parts, this is an idled system throughout the ski season in Vail.
Yeah. Okay. And let's see, do one more slide here and then I'll dig into the questions a little bit more. So this was a cool project. This is a newer one in Breckenridge, Colorado. Tell me some of the cool things about like the manifold cabinet there.
Yeah, so back to, the idea of where are we going to locate these manifolds and how do we want it to look? A lot of times the architect gets involved in these questions because they're concerned about their aesthetic and their design, and they don't necessarily want, just a metallic, looking, box installed somewhere, a utility type looking box installed in the exterior of their building. You can see it's a beautiful, beautifully designed building, right at the foot of the ski resort. So they're very concerned about the aesthetic. And in this case, this was, back to the ingenuity of our contractors who, these are the guys who always figure out the best solutions for problems out in the real world. So the contractor on site, you can see on the bottom left, they came up with a custom fabricated manifold access cabinet where they were able to maintain the stone facade that they wanted on the side of the building, but they built that into an accessible manifold cabinet where anyone walking past, this manifold location on the, when this system is up and running, will probably never think twice about what might be behind there. So I just thought it was a neat example of how innovative our contractors can be out there in the field to maintain the concerns of the aesthetic that the architect has and still provide the access that, they need for their equipment.
Yeah, I like that a lot. I think that's just kind of a nice finishing touch to a big system like that.
Yeah, I was impressed.
So this Fallsview Casino is an older one for us, and I like this one. I think this is a pretty interesting case, according to Dale Hanscom, who's our sales manager in this area. They were building this project, and they had a meeting where the engineers and a bunch of people were coming to look at the job site mid-construction, and someone, I guess their truck slid into something right there. The location of this, you can't see it from the photo, but it's right kind of on top of Niagara Falls. So they're getting snow sometimes, as you can see, but they're actually getting a lot of just mist from the waterfalls. And I guess with the high-rise construction that's kind of clustered around the falls now, those big kind of misty, made of the mist, clouds that they're creating, right off of the waterfall there don't blow away as much as they used to. So they almost kind of get hung up in these different buildings and things like that. And they've got a lot more ice developing because of it. So they decided that they were going to put in snowmelt here, and that made this whole project a much more walkable area without having to fight with just the kind of microclimate that they have right there. So that was an interesting one, and I like that project. I think that was another Climatrol designed project. So what about this this hangar? You mentioned this a little bit at the beginning, but how do they use snowmelt here?
Yeah, so this is interesting, and we've seen quite a few of these. This one here is from a project that was in Anchorage, Alaska. We've done a number of them in Fort Carson, Colorado, at the Army base where they're actually housing drones in these hangars. But there's obviously lots of hangars being built all around. In anywhere there's a cold climate, what they want is the whole side of the building can open up for the planes or the equipment to come in and out. And that has an underground track system that it runs on. So it's what they want is an ice melt system just to keep any moisture that could, ever drip down or get into that track assembly from freezing and binding up their ability to open and close these hangar doors. So some of the unique challenges from a installation standpoint and the design standpoint, like I talked about, is, one, you might have these are in these hangars, they're very thick slabs. Like I said, 14-inch, 12-inch slab, not at all uncommon. So dealing with the design considerations there might mean we need to run a higher water temperature than you might expect if our pipe is, 8 inches below the slab or 7 inches below the slab than if we were up at, 2 inches below. But then also, because they're often very long and you can't have a manifold located, again, back to our manifold location conversation, you can't put one midway out in the middle because of, again, the load rating requirements of that slab with airplanes and drones and other things coming in and out. So the manifolds have to be at the far ends. So oftentimes this might mean that we need to run 1-inch pipe because we have a really long run, or we might have to put a manifold at either end of the building and meet in the middle and go back. So they are different from a design standpoint than we would typically see, but can be very important and effective in allowing these doors to remain functional all throughout the winter in colder climates.
Yeah, I like that as just more of an industrial application for snow melt, that they just didn't have the option to have a big ice dam there. Not so much a luxury, but a critical functionality of that building. So I think that's
yep.
And that could be anywhere. That could be, this one is in Anchorage, Alaska, but that could be anywhere else that it snows, that they have a similar mechanism like that.
Correct.
So I've got a couple questions that are similar in the chat that kind of relate to using creative heat sources like waste heat or heat from some sort of process that's happening that's lower temperature. So what we can do with LoopCAD, and you can kind of expand on this as well, is model, okay, what could we do if we're in the chat here, Holland, Michigan is the example. What if we have a nice big source of 95 degree or 90 degree Fahrenheit water? Are we going to be able to melt snow with that? And how would you kind of work through that equation?
Yeah, those are great opportunities. And I like the thinking whenever we think about what our heat source are is, do we have any waste heat? We did a project in Denver at the Denver Center for the Performing Arts where they had steam boilers feeding the building, and there was return condensate. So we had excess waste heat, and we tapped on a heat exchanger onto that return condensate. And so we had this kind of free heat source. And at that point in time, even if it's a low temperature, maybe it's 95 degrees, then it makes a lot of sense to, number one, you're right, Max, we could design it in our LoopCAD software, and we can adjust that flow rate, and we could see what our capacity is. But then going back to the control strategy, that's a system where it makes sense to go ahead and idle it. And if we're idling that slab because it's waste heat, we're not spending resources to generate it, then why not idle the slab? And then we're going to stay ahead, and then we have a snow prevention system because that slab is always, we do a really good job when we're always ahead of the curve, as opposed to having to deliver the BTUs to heat up a cold slab to temp during a snowfall event. And we could be much more effective if we were idling at a low temperature, like all through the season. So when we have those opportunities anywhere in a building, it's great to think about using snow melt because it's, if we have that opportunity for waste heat, it's a great way to use it.
Yeah, and that can be all sorts of stuff, hot springs or weird applications like that. Or I think in one of the chat things here is in Denver, where they still, or in cities where they have steam systems and have the waste condensate from district heating. That can be a nice heat source too. So really anything that warms water, but I think that the caveat I would say there is that if you've got 80 degree water and you're trying to shoot for those like helipad levels of snow-free ratio and frequency distribution, you might need to bump up the temperature a little bit with the boiler or something like that. But definitely if for some reason you've got a bunch of warm water laying around, we definitely want to see if we can use that, because that can make a system creative and less expensive to operate.
Absolutely.
Okay, so we're a little bit over time here. I think we have one. What are some of the highlights of this project?
So there's another opportunity where the scope of the project was pretty significant. Essentially, the whole base village of Steamboat installed a snowmelt system, most of it under pavers embedded in the sand, and then with pavers on top. We had to use a lot of the pre-insulated pipe. There was a central boiler plant in the center of the area, and that fed out all throughout the base village, and all of the pedestrian walkways between the restaurants and the hotels and the lodges are all melted there. So this one was interesting just in terms of the scope of the job. A really nice installation there by our contractor, who this was mostly a design build, and a local Colorado contractor there who did a really nice installation on this entire system.
Yeah, and it's I have driven past this in the winter too, and this the top left photo there, you can kind of see going up the hill, and there's just this nice like kind of oasis of of dry concrete, or at least wet concrete without snow on it. That whatever the bus or something stops right there, but it's just a nice spot.
Really nice. And I guess the other thing is this was I'll say a retro in that the entire base community was pretty much well built up around here. So it was a cooperation between the different storefronts, the different lodges, the town of Steamboat itself, and there was lots of responsible parties. But ultimately, everyone who shares this base village area benefits from having that all free of snow all winter long, not having to get vehicles in. It's very attractive. We're not going to have slip and falls of skiers coming in and out of the slopes and able to go into all of their facilities. So there was a lot of collaboration between the responsible parties, and ultimately one common system that everyone enjoys the benefits of. And this was all done around in an existing environment where the landscape was turned over. This system went down, and then a really nice decorative paver system went in over the top of it.
And I think that we talk about these snowmelt systems in mountain areas because they make a lot of sense. But when I lived in Colorado and I would go skiing, I have fallen down in these areas before because you're in ski boots, and they're not the best traction to begin with, and then a lot of traffic, a lot of snow, just as a high potential for slip and fall. So I think this is definitely an A+ application, but I think just any sort of high traffic area is a good fit. So we just had another bunch of questions jump in here. So let's see. One of the questions, and you had mentioned something like this a couple days ago, Mike, experience with snowmelt on decks using pavers on a chair system with no sand, kind of a floating tile type application. Have you run into something like that?
Yes, we've seen some of these type. Maybe it's a rooftop deck area that they want to make accessible for the owners to use throughout the winter. An outdoor space like that, they have a tile system. So it becomes a little bit more of a complicated of a structure because that drainage issue is really critical. So you're probably going to be dealing with the subgrade, the top of the roof, if you will, that's going to be graded at an angle away from the building, and to channel that moisture, and then a drainage system that underlays that. So then you're probably going to be looking at a membrane system that would go over the top, collect drainage, and then it could float or sit level on chairs or something up above there. Now, if you get into a situation where there's air gaps created between that tile layer and whatever medium we're going to put the pipe in, that wouldn't necessarily be an ideal situation. It's not to say that you can't get some effective snow melting, but it would kind of like be putting a rug over the top of your snow melt system and then putting your tile over the top of that and hoping it's going to work real well. So whatever can be done at that point to minimize the air gap between the layers by either, say, maybe it's possible to put a bedding of sand up there. Practically, that could maybe be a challenge up on top of a roof just in terms of getting the sand up there and putting it in. But if you could do a more traditional sand bed with paver on top and eliminate the air gap, that could be one solution. If that's not possible and you're using other materials that the pipe would be embedded in, like an insulated foam board with grooves that the pipe's able to snap in, then you'd want to, at least if possible, get the tile system that goes above that as close to the top surface of that heating panel as possible, and eliminate any air gaps would be the only recommendation there. But ultimately, you need to provide a pathway for the drainage to go down to the membrane level and wherever the drainage collection is, and down and out and off of the roof and away from the building.
Yeah, so definitely a unique application, but those are good criteria to look at for that. So a couple of the questions related to controls. So one of the things that we could mention, and this is probably a pretty good slide, is zoning. So there are definitely some enormous systems that everything is 100% on or 100% off. There are some other projects that maybe the primary entrance to a commercial space is one zone, and then some secondary entrance that goes out to the storage unit or something like that is a completely different snow melt sensor, completely different system. There are definitely ways to zone like that, so you can prioritize which areas are most critical. If you want to idle one and melt the other, melting mode for somewhere else, that could be a good way to go. One of the questions was about
shading that might occur on the site where one area is in constant northern exposure, shaded by the building, might need to be an independent zone, or different materials. Say some of it is pavers with sand and some of it is in a concrete slab.
Especially for
those
that,
could justify being separate zones.
The snow melt sensors that we would recommend you use are not just looking for snow, but they're keeping an eye on the temperature of the surface. So if you had pavers and then you had concrete in two separate areas, you don't want to send just the same supply temperature necessarily without two different control systems there, because you would be underheating or overheating one of them. And like you talked about, maybe one slab's on the north side of the building, the other one's on the south side and gets a lot of sun. So if the sensor's on the south side, you may turn off that north side too early, and then you've got a bunch of snow that's halfway melted in the back of the building, and you don't want that either. So those are a couple things to look for. Placement of the sensors. The worst conversations to have about snow melt sensor placement is when you go to a job site and it's not working right, and you say, well, where's the snow melt sensor? And then the person who did the system is holding it in their hand still. That's a problem, because then you have to core drill that into the slab. You want it in the melted area as a general statement. It has to be somewhere between these pipes, or else it's not going to melt itself clear. One of the cool things that I saw wholesaler Greg Burney in Colorado do one time is that there was kind of a mix up where they put the snow melt sensor and the concrete guys pulled the pipe really far away from the sensor. So when it went into operation, there was kind of a big snowball on top of the sensor that never melted clear. A cool troubleshooting tip that he had is that he was trying to figure it out. They went back and they switched the supply and the return pipe. They had to add a little extension there, I guess, to make it work. But then the way that particular, routing of the pipe went, they ended up getting the warmest pipe to go right by the sensor first, just kind of by luck, and got themselves out of a bind there instead of having to core drill and move the sensor or something like that. So definitely between the pipes, kind of centered between your spacing there, is where you'd want to be. Some other things that can be tricky there: you definitely don't want it under an awning. You don't want it under a spot where maybe a truck would park and then could shield it from catching the snow all night. That could be an issue. But really, you want to put it in the most critical part of this space. So if we're looking at these photos on the slide right here, maybe the top left, you've got the disadvantage that you've got a bus driving over it all the time. You've got the advantage that it's probably the most critical first step out of a vehicle, compared to bottom right slide. If you put it up against the building there, it may not catch any snow because it doesn't blow around the building that way, or you may have a big pile of snow. It's hard to predict it exactly, but definitely think about where would be the most important first step out of a car and kind of plan around that as one way to think about it.
Yep. Yeah, those are great points, Max.
Okay, let's see. So those are going through the rest of the questions here. One thing to mention, we didn't really get into too much installation stuff here, but anytime you're transitioning in and out of concrete with the pipe, we like to use the PVC bend guides. So the concrete isn't kind of a sharp abrasive edge, maybe if you're coming into pavers or something like that too. We like to keep that pipe where it's expanding and contracting kind of away from a sharp concrete edge there, but that's just a kind of installation side note. Let's see.
And we provide some details too whenever we help out with a design, especially dealing with expansion joints and maybe sleeving some of those areas or trench drains, those types of things. We provide some detail, and that's something we can help with, when it comes time to design, dealing with some of those issues.
Yep. And then let's see. Snow melt sensor placement we talked about. That takes us through most of our questions here. There are a couple that we can follow up kind of after the call that aren't the kind of the exact topic that we're talking about here, but we can stay on the line for a couple more minutes. I know that we're a few minutes over, but it looks like we kept a big part of the group still on the call. So if you do still have some questions, feel free to chat in. That's kind of the last slide that we wanted to present. This is definitely a topic that I like to talk about. I think that they're fun systems. I think that they're problem solvers and things like that. So thank you for taking the hour to spend with us talking about snowmelt in the second season of REHAU Academy on air. And we will stay on the line for another couple minutes to see if there are additional chat questions that come in.